last video for digital logic, I think. So this is the last video in my series of digital logic refresher videos, just intended to remind you of some digital logic concepts before you jump into embedded systems and have no idea what's going on. So we're going to talk today about shift operations. Shift operations are used for a bunch of different reasons. A few reasons we might use them in a course on embedded systems. One, to manipulate bits. The second reason is that we might want to improve our embedded system performance. So it turns out that bit shift operations are a lot quicker than things like multiplying. And so if we want our system, especially if it's a system that's supposed to behave in real time, if we want all those operations to happen quickly, one of the things we might use is bit shifts. Third, it allows us to work more easily with hardware registers. And fourth, it's a way of representing data compactly. And I'm not going to unpack how all of those particular details work out in this video, but it's at least good to know that this is a reason you might use a shift operation. Again, more of that would come in a follow-up experience in embedded systems. We're actually seeing those things in practice. So let's look at a few different types of shifts. So first, we're going to start with logical shifts. And I'm going to start with the logical shift left. So let's say I've got an 8-bit number. That means we've got essentially registers from 0 to 7. And I want to shift everything to the left logically. So what we do is we take whatever the top number is there and we move it over to the carry bin, and we'll insert a 0 at the right hand side, and then everything that's here we're just going to shift over by 1. So a pretty easy operation to do, and that is how we would do a logical shift left. Shifting right is sort of exactly the opposite. So we would move anything that was previously in 0, we would move that to the right out to the carry, and we insert a 0 to the left. So we'll start with 0, and then we just shift everything over 1. That's supposed to be a 0. Shift everything over 1, and we're shifting it to the right. So if in terms of binary numbers, this means that the binary number is getting smaller. That's effectively what a right shift is doing, is making the binary number smaller by essentially 1 bit, and we're removing this last one that is there. So the other types of shifts are not logical. So we talked about the logical shift left, SLSL, and logical shift right. So those are just totally about logic. Turns out that there's another type of shift which is called an arithmetic shift. And we use these when we have signed integers. So these logical shifts we use for unsigned or uint values. But when I have signed integers, there are really two types of shifts. So first would be the arithmetic shift left, or ASL. It turns out that it is effectively identical to a logical shift left. But we also need the arithmetic shift right, or ASR. And the way that that works is a little bit different than the logical shift right. So instead of pulling in a 0 from out on the left, we're actually going to take whatever the number was above it and just preserve that number. So if it was a 1, it would be a 1. If it were a 0, it would be 0. Everything else then, including that, we are going to shift over by 1. So 0, 0, 1, 0, 0, 1, 1. And that last one goes away and into the carry. So again, the applications of shifts we'll talk about in more detail if you happen to take an embedded systems class with me. But if you are curious about how a shift works, these are the ways that you might see those. I guess we're done.